How's it going?
Great. Hey.
So TypeScript. We're going to talk about something that Microsoft did, and we're not going to be totally angry. Let's just take a moment to think about that. So TypeScript. It's not JavaScript. It is a superset of JavaScript, though. What does it give us? It gives us syntactic sugar, types, obviously, TypeScript. It gives us classes and interfaces and modules built in, and then it gives us other ES6 features that we want, like arrow functions. The class syntax is similar to the class syntax for ES6, and so we can get some of these features today and start using them in a really nice, easy way. So in other words, TypeScript is just JavaScript with types. And more, and a lot more. So we can get TypeScript really easily on any system. npm install -g TypeScript. Let's flex those beard because he's I don't know. So we npm install it, and then that gives us the tsc command, TypeScript compile, and we just compile it, and we pass it in a TypeScript file, and it gives us back a JavaScript file, and then we run the JavaScript file, and it's all good. So types. We get types with TypeScript. We can add these type annotations to our variables anywhere in there. Can you read that in the back? I'm sorry if you can't. Okay. I was really worried about font size on this. If I didn't use font family. So the first one there is a number. We have a number, a string, Boolean. This is a type of any, so we can just set it to anything. And then this one, I'm actually saying that this matter variable has to be an object that has a name and a size property, and optionally a description property, because I have the question mark in there. And that'll be a string. And then I'm setting it equal to this object right here, which we left off description, because I couldn't fit it on the slide. But that's why it's optional. And name is a string, and vendor is a size. Or, I'm sorry, 40 is a size. 40 is a number. So this is nice, and we can do that, and it's really easy to do. But we can also take that a step further and use interfaces, and create an interface for that. And then we can just use that to create kind of our own custom types. So we can have our matter variable that is of type matter, and then set it right there. So if we were going to repeat this in several places, we don't have to have that same type description everywhere. We can just use an interface instead. These interfaces exist at compile time only. Same thing with the type annotations themselves. If I have TypeScript like this up here, where first name is a string, and last name I didn't specify, because TypeScript is just a superset of JavaScript. It's all optional. I can just leave it off if I need to. But when I compile it down to JavaScript, they look the same. So it's only at compile time that we actually see this. And we can actually see in this example here, I have the TypeScript on the left, the JavaScript on the right, and I tried to compile this. And you can see that I said var name is it's a type string, but I set it equal to a Boolean. And I get a type error, or I get an error when I try and compile here, that I was trying to assign a Boolean to type string, but it still worked. So it's all optional. And it only exists there. It'll give you warnings when you compile, and you can fix it then, but it doesn't really care when it goes to JavaScript. So that's types in TypeScript. We can also do functions. We can update functions, use different types of, So in this example, this is a pretty derived example to try and match the GIF that I was working with here. If you remember this episode, Season 9, the episode is called Benderama, and he can infinitely reproduce himself by sucking in matter, and then he creates two smaller copies. And so that's what this is doing. So I have this dupla shrink, because that's what it was called in the episode. I watched it as research. I'm not joking. And it's going to take in matter, and it's going to return an array of matter objects. So here after the function, I just give it the colon and then what I actually want it to return. And here I'm getting the new size because it's going to reduce them by half. And then it's going to return an array of objects that have name and size and optionally a description to match this interface. And so when I call that, we get dancing benders. We can also have default argument values. So I can update this duplishrink function, and I can optionally pass in the scale, what I want to scale it by, and the number of copies that I want to create. And if I leave those off, then it's just going to set those to a default of 0.5 and 2. And so when I do that, then I just updated the function to actually do that, and it does the same thing. So classes. With classes, we have the ES6 class syntax that we can use. So in this example, I'm creating this vending unit, and I have the constructor function right here. And then I create a new instance of that and then log out vendor.color. And this is the JavaScript that it's compiled to. So this JavaScript is pretty easy to read. You can go look at it, and when you're debugging, it's really easy to work with and step through. You can also have TypeScript compile with source maps, so you can debug the TypeScript itself, which is really nice. One really nice thing about the syntax here is in the constructor, I'm setting public on both of these arguments that I'm passing in. So name and color. And you can see in the JavaScript that it puts out, what that means when I specify it as public inside of the constructor like that it should just automatically set this property or an instance property of name to whatever we pass in as name and color to whatever we pass in as color. So we don't have to do anything. It makes our constructor function actually not do anything else. So that's a really nice shortcut that we can use. And so we can use these classes and we can bring back the interfaces that we had, and the classes can implement these interfaces. So I have a vending unit that implements a robot interface up here, and it has these properties: an optional name, an adjective, color, size, serial number, and then it has a get catchphrase method. The question mark again means that it's optional, so we don't have to implement it, but we can. So then we have the constructor here, and it accepts in a number of things. It accepts a serial number, the color, adjective, and then we implemented a get catchphrase right there. And then we can call it. And the only thing that was mandatory in the constructor was the serial number. Everything else was optional because we provided metal and shiny. So here, I actually watched this episode for research. Those are the actual serial numbers for Bender and Flexo. They're a sum of 2 cubes, each of them. And then when they go to a parallel universe, Bender had flipped a coin and decided to get a gold finish instead. So glorious golden something. But obviously his catchphrase is chumpet. That was on his top 10 list. Sorry. I really just wanted to talk about Bender and Futurama. And
How long has this research been going on?
I had them bring it back like 3 times to see the series. And if you caught The Simpsons?
Yes.
Simpson-orama or whatever. So you can do inheritance as well. Here I've got a character class that has a constructor, and it accepts in a name property that's a string. And then I've got a professor class that extends character, and inside of the constructor here, I'm calling the original constructor method by calling super. And then here in get catchphrase, I'm calling the original get catchphrase by just saying super.get catchphrase. And so we can easily do this, this class structure and inheritance with TypeScript. Any questions so far? Okay. We have modules too. There's a module keyword in TypeScript. Here I've got delivery crew as a module, and you can see in here I've got Professor, Leela, Hermes, Emi, Bender, all of them in there. But the only ones that I'm actually exporting are the delivery crew, which is Leela, Bender, and Fry. And so if we look at the JavaScript that is outputted from that, the only ones that are ever publicly available outside of there or on the delivery crew object are Leela, Bender, and Fry. The other ones are just used internally, so we can just specify what we actually want to export from this module. So these modules are what you would use internally, like in the same file. They're not the same thing as like AMD modules or CommonJS modules, but we can do that too. We can actually use a module syntax that's built into TypeScript. It looks like this. If I have a file like this could be character.ts over here, and it has the character. I can just specify what I want to export from that file using the export keyword. Here I'm saying export equals, so that I'm setting what the export value is to the character constructor. I could also say export character without the equal sign, and then that would give me back an object that has a character property on it that then has access to that constructor. And so then down here in bending-unit.ts, I can import character. So I say import character equals require, and I bring it in. And so then I can extend character and implement robot, set everything up, and here I'm actually exporting bending-unit. And then if I look at the JavaScript that is created from this, it's just simple AMD. So we have the required and exports that it brings in. We're bringing in character and using that. And then we're returning bending unit from there. So we're using the simple AMD, and this is really easy to read. The output is, that is. You can export as both CommonJS and AMD. So if you want to have a browser version and a node module built from the same code, you just specify it at compile time. So you just say tsc -- module, and I'm specifying that I want AMD for bender.ts. And it gives me that. And then there's this thing called ambient type declaration. So this is the type file for Backbone. There are several type files that you can go get online. But basically, this is where you declare variables beforehand so that the compiler knows how to deal with them as you're working through the code. So this is great for when you have libraries that you want to use in TypeScript, but they aren't written in TypeScript. You can let the TypeScript compiler understand what each method or function in TypeScript or what each property in that library is, so that TypeScript can correctly tell you whether or not you're using it in the right way. So this is the one for Backbone. There are others as well. In this one I'm using jQuery. If people still do that, I don't even know. But I'm using this comment here. So I just tell the TypeScript compiler that this file is using jQuery. So I have a reference path to this jQuery.d.ts file. This is a type definition file. And when I bring that in, now all of a sudden TypeScript knows what the jQuery API is like. And so if I tried to say, look for all divs on the page and say .each, well, we know that .each expects a function, and it's going to call that function for every div that it finds. But if I actually pass it in a string, so that's supposed to be not a function.
Well, it's not an array either.
Yeah, it's not an array either, that's true. You can see that I'm actually getting a warning here. This is just syntactic in Vim giving me the warning. But if I actually run the compiler too, it tells me that I was trying to use a string where it's expecting a function that accepts an index and an element argument. The index is a number and the element is an HTML element. And so this one actually does work. You can see I'm using the arrow syntax here for the function. It doesn't matter, but you can use it there or use it anywhere. And so this one does work, and we're not getting a warning on that one, just on the one where we didn't correctly use it. So we can use this, and this is kind of what the type file looks like. It's obviously we're on line 3501 of the type definition file. But here's where it's describing what each returns. It returns a jQuery object, and it accepts a function that has an argument, an index argument, that's a number, and an element argument, that's a number, or that's an HTML element. And so there are hundreds of these files that you can go and just bring into your framework and use, so you can start using it right away. I had to use that, it's amazing. If you go to this GitHub URL, this Boris Yankov definitely typed, there are hundreds of type definition files for everything. There's Backbone, Angular, Dojo, lots of frameworks. That's it. Any questions? Yeah.
Why doesn't it gain more traction?
Good question.
I should save that for the top question QA.
Yes.
I have a question. When you have the ambient types,
Yeah.
does that work when you can pass in, because .each I think sometimes can do, or some of the jQuery methods can accept different types,
Yeah.
right?
You can
do more
you
than
can
one.
overload that and have multiple
Yeah.
definitions. Yeah.
What are the performance implications of using something like TypeScript at runtime?
Um,
I mean, what does the code look like?
The code is very readable, and I think that's one thing that they strive for. I don't know the exact performance implications of it. We're using it a bit at work on some internal things, and we haven't really measured that yet.
Are
That
you doing it at runtime though? You're
Sorry?
probably doing it with
Oh, yeah, I mean, it
build.
compiles down to, we're compiling it down to A and B,
Yeah.
obviously. And then just,
After it dashes down, how it runs.
it runs pretty well. It does add in a couple of globals. In places, it adds in an underscore extends anytime you actually use extend, or extends to inherit from another class, and a couple of other things. But otherwise, the code is really pretty readable. I don't know that it's, I couldn't accurately talk about the performance stuff. Yeah.
So a couple of those features are scheduled to be implemented in ES6.
Yeah.
Like classes and arrow functions and whatever. Does TypeScript, are those compatible? Will they clash? Or are they separate implementations?
That is, they're separate implementations right now because it'll work, I believe. TypeScript will work in ES3 environments. I could be wrong, I'm pretty sure. But I don't know what they'll do as those features start becoming more prevalent in the browsers.
I would guess that they're going to do the same thing that Angular does, where you give the target of what you want to compile it to. If you want to compile the ES6, then
You can do that now, actually. You can tell it to compile ES5 or ES3 right now at compile time. But yeah, it'll probably be another flag like that.
Can you mix it with any JavaScript library, or you get the file to let the compiler know?
You can mix it in, and you can have the compiler. You can either you can suppress those warnings in different ways, or you can write your own type file for that and then submit it back to that project if you want. Like that's yeah.
But if
Or,
I don't want to write it, type file,
Mhm.
I mean, should it still work?
It should. It will give you all of the. It'll say error anytime you're not using the API correctly, but it still compiles. It's not going to care. All of that is only at compile time. It won't care at runtime, or it doesn't do any kind of runtime compile checking, so it should still work. Any other questions?
So Crockford recently came out and said that classes is the worst part of ES6. Would you like to talk to that?
That talk is in my queue, actually. I have
Is it?
Oh,
I watched it last night. I fell asleep though. I know, right? I'm an old man.
No, I
I
don't.
don't say why very much.
Everybody's got
It's kind of like, that's my opinion.
There was
That's one.
an image by him.
Oh, I stopped using it.
Yeah. Well,
Yeah.
so listen to all stuff and stuff, music, classes.
I haven't watched that talk yet, but otherwise I would totally talk to that. I don't know. I use classes all the time.
Me too.
Maybe I should feel that, but I don't. Here. That's what you're talking about, pretty much?
Well, that's part of the same talk.
He's stopped using JavaScript from.
Yeah.
He's telling someone to get off their lawn.
The good parts is now a pamphlet instead of a
Yeah. For the purposes of this talk, the good parts is TypeScript, so, thank you.